This is 2024 times 2, paper 2. ASL question 9. That's the last question of the paper, and it's the crazy long question, right? But I think it's just crazy long. It's not like crazy difficult. So with what we have, some sprinkler, spring water around a circle, radius 20. Point S is the center, I think. And then there's a path of AB intersecting it. Blah blah blah. Find AB. It's probably just Pythagoras, because wait, where's the 14? S is 14 meter from the edge of the path. I think this is 14. Point S. Yeah. So I can use Pythagoras to find this part, which is what, 20 squared minus 14 squared, and then root it, and then times 2, and that's indeed what they have. And then the sprinkler rotate at a rate of 1 revolution every 16 seconds. That means the period is 16. So the period is 16. Ouch, shouldn't do that. Show that the thing rotate pi over 8 radian in 1 second. So the question is like, how much, or what's the angle that the thing rotate in a second? We know it goes through a full circle in 16 seconds. Now, a full circle is 2 pi radian, right? Because 2 pi is the same as 260 degrees. So full circle is 2 pi radian. But you do a full circle in 16 seconds. So the angle you rotate per second is 2 pi divided by 16. So that's why it's pi over 8. And then the question is, for how long is the path of AB watered? Oh, this question is so weird. Okay. Then it's really asking for the angle. The reason is because now we know for every second the thing would rotate through pi over 8 radian of an angle. So if we know the angle of the path, if we know the angle that would cover the path, that the sprinkler would cover the path, then we can find the time that the path is watered. So it's really looking for the angle. So I guess the fastest way of finding the angle is cosine rule, because if you look at the triangle, we know the radius is 20, so this is 20, but the bottom here is also 20. And then we know AB as well, it's 28.57. So cosine rule should be the fastest. So A squared equal to B squared plus C squared plus 2BC cosine A. The angle is what we're looking for. So the angle is capital A. The side opposite to it is small a. So so we can find cosine by calculate out what's going on. Square minus 20 square minus 20 squared, then divided by negative 20 times 20 times 20. Wait, 22. No 20. So no zeros. Then arc cosine. Make sure your calculator is in radian, because this question is obviously using radian, right? The angle is 1.5911. Okay, so the angle there is 1.59. We know the sprinkler would cover pi over 8 radian in a second. So the time to cover 1.59 radian would be, you divide divided by pi over 8. So it's about 4 seconds. Oh, that's a nice number. Wait, the calculator lied to me. It's not actually 4. It's 4.05. Yeah, it's too specific. Yeah. Okay. Okay, now consider a clockwise revolution. Also, it's this way. The sprinkler, when time is 0, the water is at point A, so this is T being 0. At T being T, the water crosses the edge of the path at a mover point D. So when time is T, you'll be at this point. And presumably when T is 4.05, you reach B, right? Because that's how long it takes to cover the whole path. Okay, I don't know if that's relevant. Which is of distance D, south of A. Let angle alpha, let angle beta. Find an expression for alpha in terms of T. Well, again, the thing covered pi over 8 radian in 1 second. So if it takes T seconds to go from point A to point D while covering the angle of alpha, so alpha would be pi over 8 times T. This is just weird. So it's like if you don't understand this pi over 8 in a second conversion, you would totally lose this 4 mark. You would lose this 1 mark. And I don't know. I don't think you can do part C either. Part E either. It's known that beta is blah. Corrected to full significant figure. By using sine rule. Show this. So we need to use sine rule with 20. The thing is we only know 20, but the angle opposite the 20 is not known. Well, I guess we can do 180 minus the other two. Right, so 20 over sine, the angle opposite to it. So it's pi minus 180 in radian is pi, right? Minus alpha minus beta. What equals to d over, the d means dt, because d depends on t, over sine of alpha. So dt is really, you multiply the sine alpha to that side, over that. This question is getting more and more stupid, like what's the point of making alpha is this, making a SL student do these? It's not really testing much of his math skill. I think the key is this pi minus beta, because pi is pi and beta is given here, so 0.7754, you get 3.266, which is like this value. So 0.37 minus pi over 8 t, because alpha is pi t over 8. So we get that. So if you can't do D, you can't do E. Oh, that's it. Then it's not relevant anymore? Oh, I guess it's still relevant. Okay. Then there is some turtle walking south from A, I suppose. At time t, the distance of the turtle g from A is modeled by this. At time equal to 0, how far is the turtle from A? Well, 18. You just have in t to be 0. Finally, 1 mark for something that's actually normal. Let W represent the distance between the turtle and D. What's W? Well, the distance between turtle and D, you just minus, right? So it's G minus D. Hence, find out when and where does the water reach the turtle. D is where the water is, basically. G is where the turtle is. So if the water reach the turtle, the distance is 0. So this is 0. Does it mean? Oh, it just means G equal to D. Did we then just graph? Oh, this is so dumb. I mean, what math skills have I used? Well, we kind of did cosine rule. Other than that, the only thing we did is understanding the conversion of 0.8 radian per second into a time. If we know the angle, that's the only thing you need to know, which it's not really even something you taught in the syllabus. I guess it's like, I don't know, basic math skills. Like, this is such a meaningless question, if you ask me. I'd be like, very not fun. Okay, we want that intersection, so I guess it's this one. So it's when t is 3.3488 second. Yeah, because we're solving for t here, right? That's the when. That's the when. Well, second is where. So we are just finding, well, we're pretty much finding where is the turtle or where is the water when time is 3.3488, which you can done by substituting t into g or d. Either one should give you the same result. I guess I will sub into g. That looks more reasonable. So, wait, actually, that's just the y value of the graph. It's the y value of the graph, which is 22.24. So it's 22.24 meter away from point, so this much south of point A. Yeah, so the whole key of the question is really understanding how to use this part of 8. Otherwise, just Pythagoras theorem for part A, and then cosine rule for part B, and then sine rule for part E. So I guess there is a bit of math. Otherwise, yeah.